control unit in the country being queried by the Home Office. That's something the electrical folks, I mean, back when we were trying to have this debate, the EPRI, Electrical Power Research Institute, came up and said, we want an IP address for every power pole. And we can't get them. So that's my example of we already have the problem. To query those units means they have to have a stable IP address. So I actually think that it's the very, very, very large scale of control monitoring and those sorts of interactions that are going to create more of a demand than wireless per se. Now, if peer-to-peer gets super popular, then everybody's a server. And then you're back to that problem. But I'm less sanguine about that. So let's go to NSFNet. Who knows what NSFNet was? Wow, times have changed. A measure of progress is when fewer and fewer people know obscure data about the history. NSFNet was, generally it's reviewed as the successor to the ARPANET, in the sense that the National Science Foundation funded an internet backbone and regionals. Several of the regionals became commercial networks eventually, but they created, I don't know, something like 5 regional networks and 1 backbone.
Barnet.
Barnet was one of them locally, Bay Area Regional Network. NYSERNet, and so on. Anyhow, SUR was Southeast Regional Net, I think. And that was in 1987. As many people as might know about NSFNet, they don't know that there was actually something that was equivalent to market research done before that. Because remember I said people couldn't get on the ARPANET, but they wanted to. So this whole class of second and third tier universities and others who wanted to be able to do email and file exchange and so on the ARPANET and then internet, and they couldn't because of the rules and the cost. And so there was a project called CSNet for Computer Science Network, which began around 1980. And initially it was for email relaying. That's all it could do for several years, was just email relay. And over these dial-up lines where you could only do 1200 bits per second. But it turns out that 1200 bits per second in the background, which is what email does, is okay. You can transfer a lot of data. Not if you're doing JPEGs and GIFs, but we didn't have that problem back then. If you're doing simple text messaging, you can do an enormous amount of traffic at very low speeds, as long as it's in the background. And so a whole national service was set up and run by CSNet, hooking in a lot of these organizations, and then doing gatewaying onto the ARPANET and then the internet. That was sufficiently successful that NSF said, we need to make this full-fledged so that more people can get directly attached easily and have full access, that it isn't a secondary access the way CSNet provided. And that's where NSFNet came. Well, sometimes you will see references that explain that by virtue of NSF doing this, we ended up with a precursor to ISPs, commercial ISPs, because of several of the regions becoming. But there was a more important technical point, which is generally not recognized, although it's starting to get a little bit of acknowledgement. And that is NSFNet broke the internet backbone. And this was a good thing. Up to that point, there was one internet backbone run by both Baranek and Newman, the same folks that ran the ARPANET. They controlled the routing protocol. And the routing protocol was designed for one backbone. So here comes NSFNet, and it's not run by a BBN, and it's a second backbone.
Oh, David, the BBN protocol allowed for one backbone, but the whole concept behind the ARPANET was to not allow the atomic bombs to blow out the network at any single point of failure.
The reference to the ARPANET and atomic bombs doesn't match any of the experience I had at the time, although I have seen one reference to it. The phrase that was used at that point in time that I was used to hearing was that the ARPANET was designed to have communications survive hostile battlefield conditions. I don't think anybody seriously believed you'd survive an atomic bomb because nothing survives an atomic bomb.
But it was a mesh network.
Survives an atomic bomb.
But it was a mesh network. You were supposed to be going around the city and
Yeah.
not blown away.
Well, but at that level, when you're predicting nuclear holocaust.
All right.
But by the same token, we do know that the technology survives a hostile battlefield condition because it was demonstrated in Desert Storm. Saddam Hussein's network survived just fine, thank you very much, and it was exactly that technology.
It's a big problem.
It was. But the routing protocol that interconnected, and we now have what's called BGP. Well, BGP was the result of NSFNet being attached, and it was designed to take multiple backbones. And why that's important is that really, in my mind, was the beginning of the competitive internet. Because now we can have anybody be a backbone, and that's okay. And they could have people under them, which is where we get the regionals and the locals. And there was nobody in charge, really nobody in charge of the operations side. Yes?
Isn't there this Internet 2 that's being worked on? Or speed?
Yeah, Internet 2 is a high-speed research project, and I have not yet been hearing about interesting applications. And so my current attitude is it's just more and faster.
But it's totally separate. They can't plug it in.
I haven't been tracking the details. I don't know if there's any connections or not. I know the idea is that there's not, but it's too easy to interconnect these things. Yes?
When you look at that timeline and you look at functions, what would you say would be some functions down the road that you haven't seen?
Hold on, even though we're taking too long, there is some, you're not going to like what I have, but I do have something. Okay, I have the IETF and W3C because I wanted to throw something in about the standards world, and the reason I wanted to throw that in is because that's a major piece of the sociology of building the net. And if we're going to keep building the net, we're going to need that sociology. Standards are a major part of any growth like this because you have to have common reference points, common standards, which means you have to have a venue for that. The IETF has frankly run out of steam. There's too many standards to make, too many people who don't know how to do it well. And so even if we fix the IETF, it's not going to be able to encompass all of the standards we need. Now, it turns out that the reason the W3C was created for doing web application protocols was because they were frustrated with how long the IETF took, which is why it's amusing if you look at how long it takes things to be done in W3C. And Berners-Lee has acknowledged that perhaps they were just a bit too simplistic in their model of what it takes to get standards done. But they made up for it because so many of the things they've come out with have been so poor. XML is great, but a lot of the other stuff ain't so great. I mean, from a protocol standpoint, SOAP is really poor.
What about P3P?
And I think I'll stop there because I'm not involved with W3C, and I'm not actually trying to slam them because what's interesting to me is not, oh, they're terrible and IETF is wonderful. IETF actually has got very serious problems right now, and I consider them scaling problems. You have later generations that are not as skilled and don't understand some of the core constructs. And so, in fact, what they're doing is natural kinds of design. Well, natural kinds of design, if you're trying to be diligent and all-encompassing, is you build a big system. And the thing that was interesting about the IETF when it was doing well, and still is when it does well, is that that's not the approach it takes. You take a big problem, because the problems are big. It's not wrong to say this is a big problem. What's wrong is to try to solve the whole thing at once. That's the normal thing to try to do. The right thing, which frankly the internet folks, I think, tripped into by virtue of needing to deliver something soon. And it matches exactly what the real world of product developers does when they have tight funding and need to hit a market window, is you take this big problem and you look around and you go, I can solve this a little bit right now and it will be useful and it will get me going. First of all, get me revenue. Second of all, I'll learn more about the problem domain and I'll learn a little bit about the solution domain. And then I can build the second part of the solution and the third and the fourth and build out. Now, by the way, if I get this one wrong, I haven't invested too much. I can go try and solve one of the others. That's a philosophy that anybody who does serious product work considers normal. But in the standards arena, it's not normal. And then there's the administration of the, what's called internet administration. And it's things like numbers and names. Who hands out domain names, who hands out IP addresses. And the reason that that's worth paying attention to is, first of all, it's been abused in by the media, by the print media. And the third is, it requires a different structure than the rest of the net. The rest of the net is legitimately competitive. You can have multiple backbones, multiple local ISPs, multiple providers of PCs and software, and all the rest of that. No need to coordinate any of that, other than making sure they have common technical specifications. And even there, you can have competitive specifications and let the market choose. You cannot do that for the administration of names and numbers, because they're hierarchical, and we don't know how to have the market decide which address space will win. Because in the interim, you'll have ambiguous addresses, and you'll have disconnections. You have discontinuities in connectivity. And the internet had, the original administration was done through SRI, and then eventually done by a small group, which is often referred to as a single guy, but it was actually several people, a guy named John Postel at USC-ISI. And the name of the group was the Internet Assigned Number Authority, or IANA. And he was doing that work going back into the early 70s, but since we're focused on the modern internet, I'll just say he was doing it, the interesting level of this was done when the DNS was created more than 15 years ago. And by the way, it looks like it's more than 15 years, but that's when the spec was done for DNS. It actually became useful in the late 80s. That work, that administration went fine. He was referred to as the number czar. And the term czar has caused some people to think that he was like some kind of dictator, but in fact he was highly collaborative. And when he made a decision that sort of cut through people's debate, he was allowed to do that because he made good decisions and we liked him. And I don't just mean like him personally, it was he made good decisions. And we all wanted a decision. So you debate for a while and then you move on. This all got turned into a huge political play when NSF allowed now VeriSign, then NSI, to start charging for domain names, simultaneous with court cases starting to intrude on some issues of intellectual property, namely trademark. And what came out of that was involvement all the way up through the White House. Ira Magaziner, senior White House guy, who had done such a great job of getting universal medical care in this country, that he went on to fix domain name administration. And he did that through by taking a year's worth of U.S. federal government interagency work and throwing it out, because he's brighter than they are, and saying, okay, here's a paper that's going to tell you how everything's going to work. And it was called the Green Paper because it was a draft proposal. What eventually came out was a white paper, and out of that came the organization that now runs this stuff on, quote unquote, on behalf of the U.S. government, called ICANN. What the Green Paper did, and the reason it's on this list, is that it destroyed IANA. 15 years of good operation that needed to evolve and was in fact being orchestrated for evolution was disrupted like that. Its authority base was taken away. And what we got in its place was this mythology that the U.S. government was really running this stuff, which it hadn't been. The reason that's important is it's now created an instability in a fairly important piece of infrastructure. The other reason is you hear people refer to ICANN as doing internet governance. And if you've seen those references, you want to distinguish between what is it ICANN really does, which is to administer names and numbers, and then say, now, if the people who hand out 800 numbers and hand me out my street addresses, if I said they were doing national governance, would anyone take me seriously? The answer is no. Hello. All right, so this is not the kind of